Hey everybody, it's Dr. Jensen with CCJ3701, Research Methods in Criminology. We're going to be wrapping up Lab 6 in Part 3. So again, congratulations for building this darn thing. Now we got to use it to do something useful. We want to use it to maybe answer some questions about the world and do some analyses. So let's run some analyses you're already familiar with, like ANOVAs and t-tests. So remember, for ANOVAs and t-tests, your dependent variable or your outcome variable is supposed to be interval, and your predictor variable or your independent needs to be some kind of a categorical variable like a nominal or an ordinal. And depending on how many categories it has is going to help you decide whether it's a t-test or an ANOVA. But essentially you're analyzing how much variation there is in people's responses and the numbers they provide based on some category they're in. Okay, so now we've just taken lots of just kind of yes, no, or how wrong is it type questions, and we've put it into something we can quantify a little bit better. So we've just increased our measurement power. We took some nominal and ordinal variables and combined them and made an interval variable. So we can kind of make a little bit more of a comparison, do more analyses now that we have quantities that lets us kind of see how high or how low you're scoring across lots of different abortion questions. So now I can say, okay, someone that scored a 5 versus someone that scored a 9, there's an exact 4-point difference on the strength of how they feel on abortion. And that quantity is really useful to me to do different kinds of things. So the last few questions that you have, so you've built your scale, you've answered questions 3 and 4 and so forth. It says, now run a bivariate comparison of the means between the variable called sex and your new abortion scale. So we're going to see essentially, does gender predict how you feel about abortion? So maybe we think it does, but we don't know, so we're going to test it. So first, are you going to run a t-test or an ANOVA? Okay, so let's go back in your data. We need to go look at that gender variable because we never analyze what we don't know, right? Okay. Oh, the other thing we can do since we're in here is we'll go inside the label column and we can put a label for your abortion scale. There's a couple ways to apply labels. We can just type right in that field and now we have it nicely labeled. The gender or sex variable is actually really easy to find. Just click your mouse in the variable name field, hit Control F, and type in sex. Okay, and there's a couple questions that have to do with sex. We're going to go ahead and move to just the variable called sex. So go ahead and hit find next until you get to sex. You notice there's lots of questions about relationship sex, about being paid for sex. It's kind of fascinating. Okay, so right here it says respondent sex. So it's row 664. That's where our variable is. Okay, so row number 664. Let's look at the value labels on it. 1 is male, 2 is female. Okay, simple enough. Let's go ahead and run a frequency on this and get to know it. So we'll right click it and ask for descriptive statistics. When we do so, we actually get this response. So we see 930 males and 1,093 females. So what's interesting is there's no missing data on this variable at all. So that's kind of nice. Everybody knows their gender. Okay, it's just male, female in this data set. Okay, we don't have transgender people represented and so forth, just male, female. So we think that by knowing your gender, we might be able to predict your feelings on abortion, but we don't know if that's even a relationship. So we want to run a bivariate to find out if it actually does relate and how it relates. So because this is a 2-category nominal variable, are you male, are you female? Do we run a t-test or an ANOVA? We run a t-test because t-tests are just comparisons of 2 categories. ANOVAs are 3 or more. Okay, so let's go ahead and run it. Go to the Analyze menu, and we're going to go to Compare the Means and ask for an independent sample t-test. Go ahead and click that. For the test variable, that's where we're going to put the dependent variable, which is how you feel about abortion. It depends on what gender you are. So let's put our abortion scale in there. It's all the way at the bottom. And now we just have to navigate. I'm going to display the variable names. You can kind of type in sex, and it'll actually move it to that place. It's about 3/4 of the way down. You'll see sex. Pop that into grouping variable. Okay, it's what groups are we trying to do. And then you have to hit define the groups, and you just have to put what the value labels are, 1s and 2s. So just type in a 1 and a 2. Again, kind of a weird, unnecessary step that SPSS makes you do. Hit continue. And then in options, we're going to ask for options. Everything's set up here, so actually we're okay there. If you click OK, we will get a t-test. So right here, the very first part says, okay, you have males and females, and you go, wait a second, I thought we had like 900 something males and 1,000 females. In this analysis, we only have 254 males and 332 females. Where'd they all go? Did I lose those males and females? Well, sort of, you did. If you're going to run a bivariate analysis, you have to have data across 2 variables. So any males or females that did not answer all 9 of those abortion questions that are in your scale cannot be included in this analysis. So you got to remember, building scales sometimes limits how many cases you can analyze, how many people are in your sample, how much data you have. Okay? So we have a little bit fewer than we had before. Okay? Here's the results of the t-test. Okay? So again, you get an F statistic and a t-value. Doesn't really mean anything in and of itself right there. But we get a significance level of triple zeros, 0, 0, 0, okay? And that means something. This is highly statistically significant. So basically right there, you can say it got a p-value of p is equal to 0.000. That means we have a less than 1% chance of being wrong, that there is a relationship between gender and how you feel about abortion. Okay, so number 1, that's a result. You can report that statistical significance score. The other thing you can report is the mean. So the mean is what was the average score on that abortion scale for males and for females. So from 0 to 9, males scored an average or a mean of 6.3. Females scored an average of 5.4. So what does that tell us? It tells us that males feel slightly more pro-abortion than females do, just a little bit, about 1 point stronger. And these are all things you could write up in the last part of that question. When it asks you for the statistical pieces, you want to report those numbers, 6.3, 5.4, and p is 0.000, highly significant. You could get really formal here and say, I fail to reject my hypothesis, and if you want to, I'm not requiring you to do that because I'm much more practical than that. So you can literally just say it's highly statistically significant. There is a relationship between gender and your opinion on abortion. On average, males feel more pro-abortion as compared to females. And that's kind of the substantive. So what does it mean in English? What are the numbers that you got? A few sentences on those things and write it up. Okay? Now on your worksheet, you're also asked to run another test. Okay? So now it says, now run a bivariate comparison of the means between the variable called degree and your new abortion scale. Are you going to run a t-test or an ANOVA? Well, it's hard to know. We haven't seen this variable yet. Okay? So let's go back into the data and go look at that variable called degree. Okay? So let's go find it. Put your cursor in the the variable name, hit Control F, type in the word degree, and it should take you right to it. So you can close this. It says RS highest degree. That means respondent's highest degree. What's the highest degree you earned? Okay? And again, you can go to the code book to get the formal wording on all the questions, but this is plenty for us. When we go into the value labels, we actually have LT high school, junior college, graduate, bachelor, don't know, inapplicable. LT means less than. So I completed less than high school. I completed high school. I completed junior college, and so forth. So these are how the value labels go. This is actually an ordinal variable because it increases in how much education you have, but we don't have an exact quantity. Okay, less than high school could mean 3rd grade, 8th grade, or all the way up to 11th grade, but I didn't get my diploma. So I don't have an exact quantity of how much schooling you completed. High school, you could say, yeah, I pretty much do. Junior college is also a little fuzzy because for some people, junior college is a year. For others, it's a 2-year degree. Is it an associate's degree, or does it mean I just attended junior college? We don't know. Bachelor's degree usually means 4-year, but some people have 5-year bachelor's degrees. And then graduate could mean anything, right? A master's degree, a professional degree, graduate certifications, after the bachelor's, a PhD, an MD. It can mean all kinds of stuff. Okay, so that's why this is ordinal. We can definitely know who has more and who has less education, but we don't know exactly how much. So ordinal variable has lots of categories. Are we going to run the ANOVA or the t-test? we're going to run an ANOVA. 3 or more categories means we need to do an analysis of the variance. Okay, so we're going to go ahead and run that test. Go to the Analyze menu. We're comparing the means. And we're going to run the one-way ANOVA test. Okay, for the dependent, we're going to put in our famous abortion scale. Scroll all the way to the bottom and pop that in. I'm going to go ahead and flip these to the variable names and start typing the word degree. It's right near the top, so go ahead and when you find it, pop that into the factor area, because factor is just another fancy word for independent variable. The only other thing you need to do is click options and ask for those descriptive statistics. It doesn't package them together, so we have to ask for them. We can even get a funky little graph if we want to, a means plot. Those are kind of fun to look at. Click continue and click OK. Okay, so now we have some output on a one-way ANOVA. Okay, so here's literally what the means were. So for the people that were less than high school, junior college, bachelor's degree, graduate degree, so forth. Again, the people that did not answer the abortion questions are not going to be included. Just the people that did. Okay, we didn't run our frequency of degree. How naughty of me. I broke my own rule. Okay, but anyway, we would run the frequency. We can do that quickly if you'd like. Descriptive statistics, frequencies. We can look at that variable called degree. Make sure we're familiar with it. And click OK. So this is what degree looks like normally, kind of by itself. Less than high school, and so forth. Okay, so on average, people have a high school diploma. Not as many people have a bachelor's degree or higher. So just think, when you finish UF, you're going to be joining, a very small group of people in the United States over 18 that have a college degree or higher. So congratulations. On average, it's about 24% of adults over 18 have a college degree. So feel proud. So again, these numbers are bigger because it's just the people that answered the education question. I'm going to go ahead and run my compare the means again through the Analyze menu, one-way ANOVA. All my stuff is saved, so I can just run it again. Okay, I have fresh output. So again, these numbers are smaller, people that didn't answer the question. But let's look at what we have here. This is pretty interesting. First of all, this is significant. You get an F statistic, sum of squares, degrees of freedom. Again, all parts of the equation, but not necessarily answering our question. This does. Triple zeros, highly statistically significant, less than 1% chance of being untrue, that there is a relationship between how much education you have and how you feel about abortion. Okay, so definitely there's a relationship. Okay, so you can literally list that p-value in your results. The other thing you can do is actually start describing the results of this table. So right here, it has a mean of all the different educational levels. So the average abortion score going from 0 to 9 was a 4.06 for people less than high school. And then the people with the high school degree had a 5.6. The junior college was a 5.3. For bachelor's degrees, it was a 6.7, and for graduate school, it was a 7.1. So generally speaking, as you increase in education, you also increase in your abortion score. And we know that increases in the abortion score are meaning that you are becoming more pro-abortion. You're scoring higher, answering more yeses to all those questions. Here's the means plot. This is a kind of a funny means plot because it starts out lower for less than high school and goes up higher for people that completed high school. Then it like dips slightly. So something funky must happen between people going to high school and then going to junior college. It dips a little bit. Maybe we're rethinking the world and how we feel about it. And then all of a sudden, bam, it goes up much higher at the bachelor's level and then at its highest at the graduate level. So this is like a little plot of how your opinion changes on average of all those little means from people with different education levels. So it kind of shows you the trajectory of it. Kind of fun. But now you have your statistical output, you have your substantive stuff you can say about it. You need to write that up to answer the rest of your lab. And congratulations, you built a variable from scratch. It was a very complicated variable. You ran 2 different analyses. You answered some interesting questions. You're getting closer and closer to be able to do this on your own. So if you have questions or struggled with any of this, please reach out. I'm going to be getting caught up in emails right now. I'm trying to get to everybody as best as I can. But again, please reach out. I will get to you and hope you are doing well. Thanks.